Alright guys, welcome back to the shop. We're about half a beer into the project, as we normally are trying to save some time. So last weekend, out in my shed, built a new workbench, and it's really dark over it, and I need to come up with lighting. So undershelf lights, there's like 8 million ways to do it. I'm obsessed with LEDs, but we could do with LED tape, which is so ubiquitous and spit out by the mile in China. I like LED tape for a lot of things, but not for this. It tends to be a little sparkly unless you buy all the channels for it with the diffuser that slides in. It just tends to be a little sparkly and hard on your eyes when you're doing really fine stuff like, I don't know, rebuilding a carburetor on your motorcycle. This is actually one I do really like. This is dual color LED tape, or I should say dual white LED tape. So basically we have, it's got warm white and cool white on the same strip. So you can get little controllers for it or just wire the circuits independently and get both. I really like this, but it's not what we're going to play with today. Other options we have, these rigid LED bars that you can find on eBay. This is a piece of aluminum core PCB with a whole pile of fairly bright LEDs, and these things are ridiculously bright and cheap. I mean, you can get these now $2, and you can see these are more than enough to swamp out the camera. This one, it says it's 10 watts. It's actually about 8, but the amount of light it puts out is truly ridiculous, but it's just kind of sparkly for working on small stuff. I want something a little more diffused, but I don't have a lot of room. So a couple months ago on a lark, I bought some of these, which are LED replacement, LED retrofit tubes. Now, I didn't know what I was going to use them for. These ones are built by Lou Echo. I got these from a company called earthled. I'll put the address down in the thing. So these are what are called direct wire LED tubes. There's two main types of LED retrofit tubes for fluorescent fixtures. One is a direct replacement. You just take the fluorescent lamp out, put the LED replacement tube in, and it'll run on an instant start ballast. These are what's called a direct wire tube. So on one end, you'll see it says powered. And basically you put anywhere between 100 and 250 volts across these two pins, and it lights up. It's a complete fixture all in one thing. The other end, which is unpowered, these pins are dead. I've actually opened one of these up and verified that. They're completely unconnected. They're just there for mechanically holding the lamp into a fluorescent fixture. But when I got these, I wanted to play with them, so I ended up just mangling some bullet crimp connects to fit on the end and holding the whole thing together with electrical tape. And actually, when I was working on my car and doing other stuff, I used this, and I really like the quality of light that comes out of it. It's sort of big and long and diffused like a fluorescent tube. You can see there's one dark strip on the back where the LEDs reside. But other than that, it's really quite diffused, and it doesn't flicker, and it's nice. And the other thing that's great about having these for doing something over a workshop is they're plastic. So if I hit them, they're not going to break. So this is actually a really ideal solution. But I wanted something nicer than, say, 2 crimp connects to make this work. And it took me a long time to find it. And I actually spent a bunch of time looking at eBay. And what I eventually found were these, which are designed as aquarium fluorescent sockets. So basically we have a little silicone rubber booty and a molded connector with a G13 pin spacing for fluorescent tubes. And this just makes the whole thing super stupid easy. Because basically we can just build fixtures whatever we want. And we only have to power one end, which completely changes how you can think about fluorescent tubes for projects, for doing art stuff. You want to make crazy floor lamp, whatever, because you only have to power the one end. So these claim to be 18 watts and 1800 lumens, which is going to be more than enough for over this little workbench, especially with 2 lamps. Let's check. Can we check? Yeah, we can check. So let's bring in the kilowatt, and let's fire one of these up and see what we get. So lamp is on. We'll get that out of frame so it stops swamping the camera. And nope. $18.1 watts. As close as makes no difference to the marketing. So, yeah, they're not lying. Actually, let's check power factor. 60 hertz, 0.96 power factor, which actually, that's really good. If you're looking at LED lamps and you actually check the power factor on them, they are all over the place. Not that it makes a difference on your electric bill at all if you're a residential customer, but generally it means they've actually taken a minute to care about their circuit design and their power supply, which is sort of a sign of quality. So anyway, I want to build a fixture. So what I've got is project blocks I've already drilled out. A couple of these sockets, switch, a couple of cable glands just to make things work and make this pretty and nice. And I'm going to put a fuse holder in this fixture. The wiring on these is super tiny. It's probably 20 gauge. It might be 22 gauge. It's pretty small. I like some circuit protection on stuff that I built. Just for covering one's butt, as they say. And we need a cable. Let's see. So we need, we'll just use an old IEC power cord. Just a, C13 computer power cord. We're not going to use this connector. I could put the male version of this on a panel mount, but I don't have time to cut square holes. Well, I have time to cut square holes, but only when I'm on the clock getting paid. So, these are European color code. Let's see, what are we thinking on this power cord? Okay, place your bets. You thinking EU or are you thinking US color code? Let's find out. Place your bets. EU color code. Alright, it'll make it so much easier. Not that it's difficult, it'll just make it line up and look pretty. So yeah, I have a bunch of these cable glands. These are the skin top type cable glands. These are all from scrap, basically, from things I've torn apart at work for salvage. Luckily in my job I have access to a lot of things that are being scrapped, which means having a whole lot of parts to play with. Actually, can we zoom this in a little bit more? Will that make sense? Yeah, let's zoom that out a little bit more. Just going to leave everything kind of loose for right now so we can move it around while we're wiring. So yeah, this bench that I'm putting these lights over is about 10 feet long, so it'll be 2 of these LED replacement tubes over it. And what else do we need? So we've got that in there. We'll leave the switch loose for now because it'll just make soldering it easier. So there we go. Electricity comes in here through the fuse, up to the switch, out to the 2 fixtures, one on either side. Switch turns it on and off, and then back out to neutral. All right, perfect. So we're just going to solder this all together. You could use Crimp Connects. It just depends on what your flavor of fun is. I am going to eliminate the ground wire. We're going to call this a double insulated luminaire. Basically, there's nothing metallic on this that needs to be earthed. So I don't see any reason to keep the ground wire or do anything particularly fancy with it, we'll just throw a piece of heat shrink over it so it doesn't get in the way. So, first things first, power onto the fuse holder. Make sure my soldering station is turned on. And we want power to go to the back side of the fuse holder, the rearmost terminal. Always, always, always when you're building stuff, the part, where power goes into the fuse holder is where should be the rearmost terminal. That's just sort of safety. If you are ever changing a fuse, that means the piece of the fuse holder that is still energized is the furthest away from you. So there's that. Let's see, we'll get these installed loosely. Make sure you put the little rubber booties on. Made that mistake the first time I built one of these for something else. All right. So, we will need a little piece of wire to jump to the switch. I'm sure we got something kicking around. How about another power cord? I'm basically using these computer power cords not because they're particularly nice or anything like that. It's because you can find them in the trash can and get them for free. Nice thing, if you can get things for free to play with and experiment with, if you make a mistake, you don't have to care so much because you didn't spend your hard-earned money on it. So, it's quite nice. I will admit I am a consummate dumpster diver. I just love getting stuff to play with. Especially when it's zero cost. So these little strain reliefs, if you've never played with them, they're called skin top strain reliefs. Basically, you have a cable gland that crushes down on the cable, and let's see if we can get a good picture. There we go. So you got a cable gland. There's a little set of plastic fingers, and this gland screws down and clamps that down onto a rubber grommet, and just grabs the outer jacket of the cable. They come in a whole bunch of different flavors. You can get them in metal, in plastic, and a bunch of different thread kinds. These are all PG series cable glands, which is the original German style. There's metric ones. There are a bunch of different flavors. You can get them in NPT, National Pipe Thread, just like standard US electrical stuff. The PG series or the metric series are kind of nice because there's a lot more sizes available. These are PG9, which are 9mm. But they go up all the way to, I think, 50mm. They're great big, huge ones. And also down to fairly small. So you can, huge amount of size. The PG, I actually had to look it up. I'd seen them, I'd used these things for years. I'd never actually looked up what PG stands for, and it stands for Panzergewehrten. Or actually, it's shortened from Stahlpanzerrohrgewinden, which roughly translated means steel-armored pipe thread. It was the German standard for electrical conduit. But hopefully I didn't butcher my pronunciation too much. A, I don't speak German. B, I'm drinking Danish beer. So please excuse my horrible bastardization of the German language. So power goes in to the switch, out to the two fixtures, and then we just need to connect up the neutral or return path. This is the EU color code. a lot of people, because I'm in the United States, a lot of people in the United States have a whole lot of trouble remembering the European or DIN color code. And it's actually quite simple once you remember the rhyme. Basically, blue is the sky, green is the ground, and brown is the pile of shit you'll be in if you touch the brown wire, which is especially important, not in the United States where we're running at, 115 volts nominal, but in many places in Europe where they're running 200, 240 volts nominal, it's considerably more important to not ever touch the brown wire. So we've made up our return path, our neutral, and let's put some heat shrink on it, and we'll be done. Quick little project. And this should work pretty well. So we're going to do the double heat shrink trick here, if I've got the right sizes. Yes, I know you're never supposed to do heat shrink with a lighter, though everybody in the world does it that way. The purists will get angry. So here's one other trick for doing heat shrink. Fortunately, this is black on black. It's really hard to see. If you take the heat shrink, shrink it down, while it's still hot, you can fold the tail over. And then, usually there's enough slop that you can just take that, put a second piece over it, and it basically gives you this nice little sealed up dead end connection. And that's it. So I know there's a fuse in there because I check. We'll get these how we want them. Tighten everything down here. See the Knipex pliers wrench. They're really expensive, but man, are they useful. Really nice for just many, many things. So, they're really cool because they are adjustable, but the jaws stay parallel. And I don't know what the finish they put on these is. It's amazing. These are 10 years old, and I've used them a ton at work, and I've got like little chips in the finish. It's some sort of ridiculous unobtainium coating. But man, it just works. So you can see just a little bit of tension on those, and they crush right down and grab that cable. But they don't crush the cable. They don't damage it, which is really nice. And we'll mount up our switch here. This is just a cheapo, as cheap as you can get, ABS plastic project box off of eBay, where so many electrical things are available. So many little project things are available, just so cheap. I mean, I think these little project boxes cost me $1.50 shipped. I have one remaining local electronics place, and that would have cost me, $7 or something ridiculous. So yeah. Snap the cover on. I did have to slightly modify the edges of the cover to make a little clearance for everything. But, yeah. There we go. Snap the cover on. And basically we have a complete fluorescent fixture now. As for mounting them is actually going to be really simple. The fixtures... I have opened them up and verified that the dead end of the fixture is actually not electrically connected at all. And it actually comes with these little plastic caps for just for keeping the pins from getting bent during shipping. Just these. I'll probably just put some silicone on these, and they'll stay there forever. And as for mounting, all we're going to do is do zip ties with these little screw-down cable mounts. And that's it. We've got great fixtures. They're nice and diffused, and they should work us pretty well. We'll give this a quick test before we take it out there and mount it. Fire in the hole, as they say. Well, fire in the hole if the pin's not bent. Ta-da! That's a result. All right, we'll go mount it up. I'll take the camera out there, we'll shoot some video, and it'll be beautiful. Thanks. Okay, so we're out of the basement, and we're out in the shed, and these are all installed. So, yeah, as you can see, here's the switch box we made. Probably could have made the cables a little shorter. And we just ended up mounting the things. Come on, focus. Just with zip ties. And these should last forever. These are plastic. So if they get hit, it shouldn't be an issue. Here's the switch. Turn it on. And we just get tons of light out of these fixtures. And super diffuse shadows. Should be really nice for working on small stuff like carburetors. Or when we're detail painting, doing all the stuff that we don't usually do in the house because it's too stinky. But yeah, that's it. As for cost on all this stuff, the project box and the switch and all that, that was junk box stuff. These sockets, these sockets were from eBay. Search for T8 waterproof socket. They should come right up. There's a million places in China selling them, and I mean, with shipping, $3 a piece, less than that even sometimes. And the LED replacement tubes, those were sub $10. I mean, $8.99, $7.99 on sale. Just look for direct wire ones. You basically just want ones where you put power, 120 volts or 250 volts, whatever you're working at in your country, across the end, and you're done. And just, I mean, look at the amount of light that's coming out of this. Let me see if I can zoom back out. I mean, you can see the camera's just determining that that's the brightest thing and irising down. But yeah, should be good for a bunch of years. Thanks for watching.